This, this video goes over polynomial functions. The first question says, which graph could represent a fourth degree polynomial function with a positive leading coefficient? That means both ends are going to point up instead of down. So the ones pointing down are out. 2 real zeros and 2 imaginary zeros. Zeros are where the graph crosses the x-axis. The real ones specifically actually cross the x-axis. Imaginary zeros you're not going to be able to see on your graph. So out of the 2 that are left, option 1 crosses the x-axis 2 times, whereas option 2 crosses the x-axis 4 times. I can only have it cross the x-axis twice since there's 2 real zeros, so number 1 is the answer. The next one says, sketch a graph of a polynomial function given the criteria below. P of x has zeros only at -5, so 4, 5, right here, 1, and then 2, 3, 4. So I can't cross any more times than this. As x approaches infinity, this is the right side of the graph, P of x approaches -infinity. This means that the right side points down towards -infinity, and this is the left side as x approaches -infinity, so the left side also points down. So if I just try to connect, if I start with a side that's pointing down, it's going to have to go up, and then if I just cut through both of those, it'll point back up. So I need to just have one of these be a tangent point. So I'm going to go like this, points down, right? And then again, I can't cut through this and come back up because it won't point down. So I'm going to just touch it, turn around, and then have it point down. So it's a little tricky. Number 2 says, which graph has imaginary roots? So you're not going to see it. So you're not going to see them at all, touch or cross the x-axis. This touches the x-axis, so no. This touches the x-axis, no. This one looks good, it doesn't touch the x-axis. This one touches the x-axis, so option 2. 5 says, which graph best represents the graph of x plus a squared? Now, if you were trying to solve this using factoring, you would set it equal to 0 and you would solve. So you would get x equals, and the sign would flip. You'd get positive b, and you would get negative a. So the other thing that we talked about is multiplicity. So since this one is squared, that means the graph is going to be just touch and turn around at that point. We call that being tangent to the x-axis. This only happens if we have a squared. This is called a multiplicity of 2. So at the negative x value, we're going to have a tangent graph. Okay, so here's a negative x value, and the graph is tangent. That works. That's one option. Here's a negative x value, and you have a tangent graph. That works. The other 2 cross 3 times. 1, 2, 3, 1, 2, 3. Those 2 are out. So after you narrow it down to one of these, the other thing is the leading coefficient. So in front of this, there's no number, but we know that if nothing is there, it's 1. Specifically, in this case, a positive 1. So what does this mean? A positive value at the front means that the graph is generically increasing. Increasing would look like this. Now, because it's curved, it's going to have this general shape at the ends, but not in the middle. So it starts low and then ends high. That would mean it's positive. This one is negative because it starts high and ends low. So it has to be option 1 because it has a positive leading coefficient. All right, The average cost of a gallon of milk in the United States between the years 1995 and 2018 can be modeled by this equation. P of t represents the cost in dollars and t is time in years since January 1995. During this time period, in what year did P of t reach its maximum? So let me throw this into my calculator. Negative point. And then instead of t's, I'm going to use x's. Okay, I can't see much of the graph, right? So let's go to the table. All right, so number of years since 1995. So let's just check our answers. So 1995 is 0 years since 1995, and the y value there was 2.6602. So we're gonna find the maximum. Now 2014, 2013, and 2018, we're comparing these to 1995. So this was 18 years since 1995. We'll check out t equals 18. Oops, I know you probably know this answer, but 19 years. And then 2018 is 23 years. So let's go to my table and check out 18. 18 is at 3.751. And then 19 is at 3.747. And 23 is at 3.479. So I'm looking for the one that has the highest value, which would be 3.751. That's a maximum. Maximum is the highest. All right, 37 says a manufacturer of sweatshirts finds that profits and costs fluctuate depending on the number of products created. Creating more products doesn't always increase profits because it requires additional costs such as building a larger facility or hiring more workers. The manufacturer determines the profit in thousands of dollars as a function of the number of sweatshirts sold, X in thousands. This function is shown below. Graph P of X over the interval 0 to 9 on the set of axes below. So I'm going to just type this into my calculator. Let me make sure I typed it in right. Looks good. I'm going to go to the table and I'm going to start plotting the points, and we're plotting 0 to 9. So they're saying that this is 30. They're giving us that scale, and they're giving us this scale that this is 1. So this will be 2, 3, 4, 5, 6, 8, 9. We don't have to go any farther than that. If this is 30, then this would be 15. We could start counting by 15s. Negative 15, negative 45, negative 60, negative 75. All right. All right, let's get a few on here. There we go. All right, so I'm going to plot some of these points. So I'm going to plot between 0 and 9. So 0 is at negative 69. 0, negative 69 is somewhere in here. 1 is at negative 66. 2 is at negative 47. 3 is at negative 18. 4 is at 15. 5 is at 46. 6 is at 69. Oops. 7 is at 78. 8 is at 67. 9 is at 30. So we have this curve. Just that little piece of it. It says, over the given interval, state the coordinates of the maximum of p and round all values to the nearest integer. Explain what this point represents in terms of the number of sweatshirts sold and the profit. Now, round to the nearest integer. I'm just going to confirm that my answer is going to be 7. And to do that, I'm just going to look at my calculator and I'm going to change the window so I can see the graph better. So my graph is currently going from -10 to 10. I want it to go from 0 to 9. So I'm going to make my x min 0, my x max 9. Then I'm going to do the y min, and I'll make it like -75. And the y max, I'll just make 90 like I did on my calculator. The scale is going by 15, so I'm going to change the scale too. When I hit graph, I can see this a little bit better. So it looks practically like what we just graphed. If I hit second trace maximum, it'll say left bound, so you can go to the left of the maximum and hit enter. Then you go to the right of the maximum and hit enter, and then you can guess and hit enter. So the maximum is at 7, and y value is 78, just like we thought, but just confirming. So the maximum of p is 778. And then let's see what this, explain what it represents. So let's go back to the beginning. It says the x value was the manufacturer determines the profit as a function of the number of sweatshirts sold, x, in thousands. So after selling 7,000 sweatshirts, and then p of x, which is really y, is the profit in thousands of dollars. The profit is $78,000. So just pay attention to if it has units like this one does, thousands. All right, the next question says, in the quadratic formula, b squared minus 4ac is called the discriminant. So that's just like a random word. The function f of x has a discriminant value of 8. So the quadratic formula is on the reference sheet. This is the discriminant they're saying. The function f of x has a discriminant value of 8. So that means for f of x, which is neither of these two graphs, by the way, f of x, if you did the quadratic formula underneath the radical, there would be an 8. G of x has a discriminant value of -16. So g of x, there would be some other stuff, but underneath the radical would be -16. And then we have these other two graphs, h of x and j of x. It says, which quadratic functions have imaginary roots? So imaginary roots means they don't cross the x-axis. So the graph is easy to tell. H does not have imaginary roots because the roots are right here. J does have imaginary roots because it doesn't cross the x-axis. So we definitely want to pick an answer with J. So we're down to 2 and 4. Now the other info that's given is this. So underneath the radical is an 8, and underneath the radical is a -16. So if I type in square root of 8, I get a regular, well, I mean it's a decimal, but I get a regular old decimal. If I type in square root of -16, I get an imaginary number. So G is also going to have imaginary roots. All right, 18 says the graph of f of x is shown below. In which interval is f of x always positive? These are not points, these are intervals. So this is saying from x equals -2 to x equals 4. So x equals -2 is right here. to x equals 4, which is right here. Is this graph always positive? No, it dips below the x-axis. Let's try the next one. So I'm going to cross them off when I'm done. X equals 0 to x equals 10, 8, 9, 10. 0 to 10, this is always below the x-axis, so that's not always positive. Okay. So now let's go negative 12, 8, 9, 10, 11, 12. That would be down here. To 0, which would be here. Is it always positive? No, because part of it's negative right here. So it's probably negative 10 to 0, 8, 9, 10. Negative 10 is here, to 0 is here. It is always positive here. Option 4. (24) says, the graph of a polynomial function is shown below. If p of x is written as a product of linear factors, so in factored form, which factor would appear twice? So the one that'll appear twice is the one that's associated with this point where it's tangent. So we've got, this is happening at x equals negative 2, but this is not the factor, right? If you factored, the answer negative 2 would come from a factor of x plus 2. So I'm looking for option 2 there. Number 9, which function has the characteristic as x approaches negative infinity, that's the left side of the graph, and then f of x goes to negative infinity, so it's pointing down. So on the left side of the graph, it points down. This is not happening. The left side of the graph points up. Oops, not on number 1. The left side of the graph also points up on this one. So it's got to be one of these other two, but let's graph them to figure this out. Oops. I'm going to change my window. If you've watched this whole video, then you know I changed my window. A quick way to change my window back is to click zoom, and then 6 is standard zoom. Okay, I typed something random in, but okay. 5 and then 4 to the negative x. So if I graph that, I'm looking for a graph that on the left side, it's pointing down. No, the left side of this graph points up. So it's probably option 4, negative log base 5, math, alpha math, and then negative x. The left side of the graph is supposed to point down, just barely, but it does. It's not like pointing down like these graphs are pointing down, but it's getting slowly lower and lower and lower. So 4 is the answer. Ooh, you can't really see that. 4 is pointing lower and lower, and on the left side it's going lower and lower and lower. All right, Patricia creates a cubic polynomial function with a leading coefficient of 1, which is positive. The zeros of the functions are 2, 3, and negative 6. All right, so we would have to go we're gonna connect all of these, and then we'll be good. The last one says, which graph shows a quadratic function with 2 imaginary zeros? Imaginary zeros just means that it doesn't cross the x-axis. So 1 and 4, and 2 of them means it has to look like a quadratic. So that would be option 2. That is it.